In the last part of this lesson, we're going to look at different types of solutions for linear systems. You may be familiar with this, you may not be. Either way, we'll just take a quick moment to review some terminology that goes along with these systems of equations, again, so that we have some common understanding. So I'll sketch in some graphs here. These don't have to be of any particular precision. We just need to get the pictures up here. Okay, and we'll go ahead and put some lines on here. So when we're talking about systems of linear equations with two equations and two unknowns particularly, there's several things that can happen when we start graphing lines on a plane together. We can get a single intersection point. We can have the two lines coincide, which is really just a fancy way to say that the two lines are on top of each other. And I'll do my best to kind of illustrate this without completely erasing both lines. And the other option is, of course, that you could have them end up being parallel to each other. Creating no solution because there's no intersection between those two particular lines. So here we have the three different scenarios. And we just want to grab some terminology that goes along with these. So here's what we get. The singular solution is referred to as consistent and independent. The two lines that coincide or overlap is infinitely many solutions. And that's referred to as consistent and dependent. Finally, the no solution scenario, where they're parallel, is just inconsistent. So this is really an attempt to try and distinguish between the two situations that we have where we have solutions. So you'll note in each case it's consistent when we have a solution, and when we do not have a solution, it's inconsistent. And then we get this distinction about independent and dependent between the two different types of solutions we get. And this is the way that I remember it. Between the two consistent graphs, the overlapping lines is said to be dependent because the solution you get depends on where you are on the line. For the singular solution situation, it's independent of choice. We do not get to choose what the solution is there because there's only one. And that's generally how I think about it. The graph with no solution is just plain inconsistent because it doesn't actually have any solution. So that's how I remember it, and hopefully that'll help you.